It's past 9.
The Radio Wammo Breakfast.
Live from the New Scientist Labs, Janine Young, newscientist.com.
In Melbourne City, of course, Janine Young is with us. Good morning, Janine.
Good morning, Wammo.
A couple of great stories. First up, today we're talking about the cane toads. Now, if there's one thing I know about the cane toads, Australians hate cane toads.
You've got that right, particularly if you live in the northern parts of Australia, which is where they were originally introduced to. They were brought into Queensland into the 1930s because they were meant to eat a beetle that was eating sugarcane, and that only grows up in the north. It's a tropical crop, as most people would know. Unfortunately, they were a little too successful. They ate all the beetles, but then they started eating a whole bunch of other things, reproducing, and started migrating west. They've now made their way up to the northern parts of Western Australia. And yes, everybody in Australia hates cane toads. They're ugly, they're poisonous, they damage our wildlife, they're a real pest. And there's competitions each year in Queensland with golf clubs and the like to see how many people can whack them. It's pretty awful, yeah. But they are a pretty awful species. Now, there has been a great deal of concern over the years about what's going to happen as these travel west. There are a whole bunch of creatures that eat frogs, snakes, crocodiles, goannas, native birds. There's a whole bunch of animals that eat them. And because they're toxic, they actually kill anything they come in contact with. So it's been a bit of a fear of a major catastrophe in terms of the environment, what's going to happen to the animals that live there. And while it has been bad in the last few years, they're finding it's not as bad as they thought it was going to be. Initially, when creatures like goannas came across, they're a type of lizard for anyone who's never actually encountered a goanna before.
Yeah.
Large lizard. They 96% of them died. So that shows how toxic those creatures are. But the benefit is that because they then ate large ones, those that did survive took on the little toads that only made them sick. It didn't actually kill them, and they learnt not to eat them again. Same sort of thing has happened with crocodiles, and unfortunately the news is not quite so good for the northern quoll, which is a type of marsupial. It's hard to describe what it's like. Quoll, Quoll.
Yeah.
Google is probably the best way to find out what it is for people who don't know.
Yeah.
It's kind of hard to describe. They're perhaps not recovering as well as some of the other creatures are, but they've got other environmental pressures on them. Fires have gone through, and there's a whole bunch of issues around climate change that are affecting them. However, this is the cool thing, I've known about this for a little while, quolls as a young baby, teenager type quoll can be taught not to eat them. Oh. You can lace these frogs with drugs that make them feel a bit sick, and they decide very quickly that they don't want to eat them again. So you can train them not to eat baby cane toads.
Oh, there you go.
I think that's the best news ever.
Well, because for a long time we got this impression that the cane toads were on the march, almost like armies of these cane toads, marching south, and we're basically going to take over the whole country. But that's not really the case, is it?
They are travelling. They're certainly going west, and they are travelling south, and there are a lot of them. I wouldn't say that it's not a massive problem, because they do cause damage to the environment. They do eat a whole bunch of animals. They do compete with other frogs, although evidence is suggesting that the environment is absorbing them. The benefit, apparently, is that they actually eat a lot of frogs' predators. Go figure. Who would have thought? So while, yes, they are travelling, it's just not quite the big catastrophe as people expected it to be, but it is still a significant problem because they are travelling a lot further and a lot faster than people had ever expected.
Yeah. Okay, right, on to the next story then. Let's look at some of the great scientific ideas down through history that have been world-changing.
And a lot of these ideas started out as very basic fundamental research that people couldn't actually see any use for. Electromagnetism, the very basis of what our world works on these days, was discovered by Michael Faraday in around 1845. He came up with the field theory of electromagnetism. He noticed that the needle of a compass was jumping around whenever it was near a magnet. Now what happens is you actually get a current set up when you have a magnet. The two go together, and that's why you end up with electromagnetism. Originally, he took it to the Prime Minister in Britain and said, well, here you go, here's a thing. And apparently he said, well, what's it good for? And he replied, well, what use is a newborn baby? They didn't know what to do with it at the beginning. They did try and turn it into a commercial success, but they didn't have the technology and they didn't have the ability until probably about 50 years later. So you can have a really good idea, but it's not necessarily clear at the time what it's good for.
Yeah.
Other examples of stuff that has become important, and I say stuff because there's a whole bunch of different examples in the article, ozone monitoring. The British Antarctic Survey had been monitoring ozone levels for 50 years, a really long time. They were using quite an old instrument. Budget cuts were going through in the 1980s, and they figured, well, no one really cares about ozone layer anyway, except until there were 3 researchers who said, actually, I think you'll find that the layer is actually getting less. More ultraviolet light is coming through, and we, in fact, have a problem. So the old saying that, all science is physics or stamp collecting information, in other words, turned out to be quite crucial in this case, because without that, we wouldn't have known that we did have a depletion in the ozone layer, and that we had potentially all the knock-on effects, and we all know what happened with that. So there's a bunch of different things that have been discovered over the years that have either been, not known at the time, or have in fact turned out to be known, but no one really knew the importance of them.
You've got one more example for us. What's another idea that at the time seemed like meh, but now is really important?
There's a whole bunch of them. Very sad story of a guy called Paul Camera in 1926. He was doing experiments in frogs. We're doing things on frogs this morning, clearly.
Yeah.
He was looking at how you could actually change their breeding behaviours. They were meant to breed on land. They bred on land. They're quite unique in that respect. And he found if you put them in unusually hot and dry conditions, that he could actually make them breed in water. That's one thing, but what's really interesting is that when those eggs hatched, the next generation also bred in water. And so he glimpsed something that's now known as epigenetics. It means that you don't get changes to the underlying DNA structure, but you do get changes to the way genes are expressed. Now, it's quite complicated in the number of different ways it can work, but that's what he glimpsed.
Yeah.
Unfortunately, he was ridiculed at the time in Nature, which is one of the most prestigious magazines still, basically saying he was a fraud.
Right.
And 6 weeks after that happened, he committed suicide. It wasn't until 50 years later that someone else looked at his work and realised that he had actually glimpsed epigenetics, which is a really, really important thing now. But everyone just thought, oh, no, he's making it up. But they actually believed that his work may have been tampered with by the Nazis because he was a socialist sympathiser, was about to set up an institute in Russia. They saw him as a threat, tampered with his work, and he ultimately committed suicide. Tragic story.
Yeah, history is littered with scientists and innovators and thinkers who just obviously thought of these new things well before their time.
Absolutely. Flying machines, for example, in the late 1700s, George Cayley worked out how it happens. A guy called Girolamo Cardano in the 16th century worked out imaginary numbers that are now critical for underlying everything from quantum mechanics to the way our iPods work. The recognition of bacteria in the late 1600s. All these different ideas were ridiculed at the time. Well, they just didn't know what to do with them. So I think it highlights how important fundamental basic research is. Yeah,
I sympathise with some of these people sometimes, Janine, I just sometimes think, I'm a little bit...
It's hard being a creative genius.
No. Thanks very much, Janine. If people want to check out more of those ideas, and there's heaps of cool ones in there that... proved to be very, very important indeed. They are in New Scientist magazine, which comes out next week. Of course, also check out newscientist.com. Janine, we'll catch you next week. See you later.